Imagine streaming a pristine 4K live broadcast across a 2-mile corporate campus. A standard copper cable would, turn that signal to absolute mush before it even left the building. So how does it get there without dropping a single frame? Well, the secret is a piece of hardware roughly the size of a pack of gum.
A very specific, highly engineered piece of hardware, I should
Yeah,
add.
exactly. Welcome to today's deep dive. We are looking at a highly technical product page from HDTVSupply for the Atlona NETGEAR AXM761 SFP plus fiber-optic transceiver module. Our mission today is to cut through all the heavy IT jargon and, figure out how this little device acts as the invisible backbone for massive audiovisual networks.
Yeah, and whether you are an IT pro building out a system or you're just curious about the magic behind flawless video streams, this deep dive is definitely for you.
Okay, let's unpack this. Instead of just calling it a piece of hardware,
Yeah.
can we think of this transceiver as an incredibly fast translator, like a high-speed digital bridge?
Yeah, that's a great way to look at it.
Because it sits right at the edge of your standard network switch, taking normal electrical computer signals and instantly translating them into microscopic flashes of light.
That's exactly what it does. And what's fascinating here is the sheer density of technology they've packed into that translator. When you actually look at how they engineered this, it fits directly into the standard interfaces of NETGEAR M4250 managed gigabit Ethernet switches.
Okay, so it plugs right into the existing gear.
Right. And the specs read like a heavy tech manual. It complies with SFP plus MSA standards, uses LC duplex connectors, and operates at exactly 1310 nanometers.
Wait, let's translate those specs for a second, because 1310 nanometers isn't just a random number, right? That is a specific sweet spot in the infrared spectrum where light can travel through glass fiber with almost zero signal loss.
Precisely. All of that precise engineering allows it to push massive data rates up to 10 gigabits per second. And those LC duplex connectors you mentioned just mean it uses a standard, secure dual fiber connection. One fiber to send the light and one to receive it.
Got it. But wait, let me push back on a different feature listed in the source here. The documentation heavily emphasizes that it's fully hot swappable.
Yeah, the hot swapping is key.
But does that feature actually matter that much? Can't an IT admin just wait until 2 a.m. to restart a switch for an upgrade? Do you really need to do it live?
Well, in a small office, maybe. But think about a hospital, a live global broadcast, or a 240/47 data center. 2 a.m. downtime just isn't an option.
Oh, right, of course.
Hot swapping means you can plug and unplug this module while the system is completely live without crashing the enterprise network. And the way it works is brilliant. The connector pins inside are actually staggered.
Staggered? How does that help?
Well, when you slide it in, the ground pins make contact first. That protects the delicate circuits from electrical shorts before the data pins even touch.
Ah, that makes perfect sense. That's incredibly convenient for maintenance, especially when dealing with those zero downtime environments.
It really is.
But, pushing 10 gigabits per second inside a server room is only half the battle. Because here's where it gets really interesting. We aren't just talking about crossing a room. The physical distances this tiny module can cover are staggering.
They really are. Because pushing that much data is useless if it can't reach the next building.
Exactly. The specs say using multimode fiber, it pushes data up to 550 meters. That's about 1,800 feet. But if you switch to single-mode fiber, it reaches up to 2 kilometers, or 1.2 miles.
Right. And we should probably clarify how it achieves that. Multimode fiber has a wider core, allowing multiple streams of light to bounce along the inside.
So it's cheaper, but the light scatters over distance.
Yeah, exactly. Single-mode fiber, on the other hand, has a tiny microscopic core that forces the light into one direct, laser-focused beam. That's why it can shoot that signal 1.2 miles without degrading.
Which completely bypasses the limits of old-school copper cables that hit a hard wall around 100 meters.
Exactly. And if we connect this to the bigger picture, this extreme reach is why Atlona offers these specific modules as accessories for their OmniStream AV over IP systems.
Right, for those massive setups.
Yeah, to push pristine, low-latency audio and video across sprawling environments like huge data centers, university campuses, or massive enterprise headquarters, you need these ultra-reliable, long-distance fiber links tying multiple switches together.
It turns isolated local networks into one sprawling, campus-wide nervous system. So what does this all mean for you? Ultimately, this little transceiver module is the critical missing link.
It really is the invisible backbone.
Yeah, it takes standard Ethernet switches and allows them to talk to each other flawlessly over miles of fiber optic cable, keeping the most demanding, data-heavy networks running without a hitch.
It's a perfect example of how massive, complex infrastructure is completely reliant on the smallest, most precisely engineered components.
It really brings us back to that initial secret we talked about. Flawless 4K video traveling miles in the blink of an eye. I want to leave you with a final thought to ponder.
Go for it.
Consider how the hard limitations of our physical world like sheer distance and scale are being completely erased by invisible microscopic pulses of light operating at exactly 1310 nanometers. If a device the size of a pack of gum can instantly bridge 2 miles of space today, how might this invisible light-based infrastructure reshape the future limits of massive digital campuses?